Antonio Joven Romero. I am a student at the National University of Distance Education, UNED. I am taking the Bachelor in Mathematics, and this is a project for the subject Scientific English. Actually, it corresponds to the activity number 6 of the subject. I'm going to talk about complex numbers, complex analysis, and especially or specifically about the differences between the studies we take about this topic in high school and what we're studying now in the Bachelor of Mathematics at UNED. So first of all, when we are at high school, we deal with complex numbers in a very easy and simple way. We say that this is just a subset or better said, a kind of numbers related, or a subset, yeah, of R2, real 2, RR. So it's a set of two different real numbers that we can write it as one real number plus the complex unit and another real number. What is the complex unit? The complex unit is the beginning of the problem. It is actually the square root of -1. Previously, they told us it had no solution. Now we invent a solution, which is I. Then we studied three different ways to represent these complex numbers. The binomial form, the one I have already explained, and then we can also represent it in two other forms, the polar form and the exponential form. As I said, the basic idea, or what they taught us, is that the complex numbers is just a subset of R2, or two different or two real numbers. And then we also deal with some basic issues like the calculation of the absolute value or the complex conjugate of the conjugate, which is basically a or one real minus the complex unit and another real. And finally, we also deal with the full basic operations or calculations applied to complex numbers: addition, subtraction, product, and quotient. And we also study some of the properties or basic properties, general properties that these numbers have. However, now in the bachelor, we are learning that complex numbers, we are not only learning complex numbers, we revise actually complex numbers in the subsequent subject in chapter number 1, complex analysis. But we also learn some other things, and the basic idea is about functions that send one complex number into another complex number. And from there, we go into power series. We studied some elementary functions, and if we have functions, how can we make integration into these functions? We also learned that just using the basic principle of the contour integration. Integration of complex numbers seems to be difficult, so we learned some basic results or theorems that allow us to make all these calculations easier, like the different Cauchy's theorems and related theorems, like Liouville's theorem, and we also deal with integration of Riemann-Stieltjes and Lorentz series. And then in the second part of the subject, we dig deep into complex numbers and complex functions, and we also study the concept of zero of an analytic function. And we study the isolated singularities, a very interesting theorem, the residue theorem, and then we apply it to integration of complex numbers, of complex functions, in order to make it easier. And finally, in the last chapter of our subject, we also introduce or learn some introduction to some basic topics about complex numbers, specifically the conformal map, the Mobius series, and the related Riemann mapping theorem. But apart from that, I would like you to focus on this picture and the picture before too, because if I previously said that complex functions, they send that we haven't studied at high school. we just studied complex numbers. But if complex functions, they send a complex number into another complex number, we are dealing with two dimensions on the one side and two other dimensions on the other side. So how can we represent that? How can we represent this four-dimension scheme? So very interestingly, we take the three dimensions, but we also use colors. In that way, we can learn, we can represent these functions better. So just here we have an example of a complex function and the representation with colors. We have an idea. It's interesting to see that it's all the three, and we have three white points which are zeros. I mean, this is not the scope of this presentation to focus on these specific topics of the subject, but we can get a general idea of the representation and of some of the basic problems and concepts of the subject. Finally, I would like to introduce or to mention some of the applications of complex numbers. They are very useful. Actually, they are necessary to study waves and signal processing. Also to study AC circuit analysis. AC stands for alternative current. It's also important to deal with quantum mechanics. If not, it's impossible. And they are also used for security issues like cryptography in order to guarantee safe use or safety or security in different kind of online transactions. So if we focus on subjects or fields that use these numbers and use this theory and these functions, obviously physics and different applications of physics or branches of physics like electronics, electromagnetism, and we also use these numbers in computer sciences, mechanical and civil engineering, and as I already mentioned, in control systems. So thank you very much for listening to me. I hope you enjoyed this presentation.